So we begin with the sixth problem in this series, and the sixth problem in this series is problem number 1.204. And the problem is stating, suppose we have made a model of the solar system scaled down in the ratio eta, but of materials of the same mean density as the actual material of the planet and the sun. How will the orbital period of the revolution of the planetary models change in this case? So over here, let us first of all understand what exactly the problem is trying to say. The problem is trying to say that if suppose we have a sun of mass m and a radius capital R, then it means to say that the radius will come down to R by eta, but the density of the material will remain the same. So this is what the problem is emphasizing on. So if we begin this problem, we say that we have a general formula for the time period, and the time period of the planet is given by T equals 2 pi by root over gm a to the power 3 by 2, where capital M is the mass of the sun, so over here if we consider that this is the original time period value, so I am writing T naught equals 2 pi by root over gm a to the power 3 by 2. So over here I am putting mass as density into volume, so we write it as 2 pi root over gm, then we instead of mass we write density into volume, so we write G density into 4 by 3 pi r cube, where over here capital R is standing for the radius of the sun, A is the length of semi major axis to the power 3 by 2. Now we write, since the model is scaled down by eta factor, so the model is scaled down by eta factor, then over here we say that R nu is equal to R by eta and A nu is equal to A by eta. So if we rearrange these terms, then we will get T nu, or the new time period. So therefore the new time period that we obtain equals 2 pi by G rho 4 by 3 pi r cube by eta cube square root a to the power 3 by 2, so a by eta to the power 3 by 2. So over here we can say that since this term is in square root, so this will also become 3 by 2 and this is also 3 by 2. So this expression is going to take the form 2 pi root over 0 4 by 3 pi r cube square root a to the power 3 by 2. So over here eta to the power 3 by 2 and here eta to the power 3 by 2 will cancel each other out, and over here we can see that Tn is equal to T naught. So we can say that the time period of the revolution will remain unchanged. You can say that the time period of revolution will remain unchanged. So this is how we solve the problem number 1.204.